Let's take a look at these questions on composition of functions. For each of these 6 questions, we need to calculate f composed with g and g composed with f. So let's start. F at g of x would be what? Well, let's do it like this. G of x is really 3x. So we'll replace g of x by the formula that it is, namely 3x. Now, what does f do to something? It says 2 over that thing plus 1. So it would be 2 over 3x, not x, right? 3x plus 1. Okay, so what about the other question, g at f of x, g composed with f? Well, let's replace f of x by its formula, namely 2 over x plus 1. And what does g do to that? It multiplies. What does g do to anything? It takes 3 and multiplies it by the variable. So what we want to do is multiply this quantity inside the brackets by 3. And that gives us 6 over x plus 1. All right, that completes A. For part B, what is f of g of x? We'll kind of use the same method. G of x is just a number 3. So actually, g of x is the constant function 3. So really, all we need to do here is find out what f of 3 is. So we just replace x by 3 and work that out. So that's 3 to the power of 3 is 27, and 2 times 27 is 54, minus 9 plus 4. So that's 58 minus 9, which is 49. All right, what about g of f of x? Well, f of x in this question is this cubic. Let's make that replacement. Now this is going to be easy because g of anything is just 3. So g of this polynomial is just 3. So that turned out to be easy. Okay, so we're on question C now. What is f of g of x? Well, let's replace g of x by its formula, which is x squared. If f of anything is that thing cubed, then f of x squared is that thing cubed. And so we get x to the power of 6. How about g at f of x? G composed with f. Well, replace f of x by x cubed. And what does g do to something? It just squares it. So we want to do x cubed squared. And we also get x to the power of 6. You know, most of the time when you do f composed with g and then g composed with f, you don't expect to get the same thing. For example, on these problems here, we saw that they're different. But sometimes, like in this question, you do get the same thing. Okay, question D. We'll start off with f composed with g. So in this case, g is 1 over x. So make that replacement. Now f of anything is 1 over that thing. So this is like 1 over x. And 1 over x is just x. And the other one, well, you know, f of x and g of x are the same here. So we expect that these are going to turn out, this should be the same answer, right? But let's carry it out anyways. F of x is 1 over x, so I make that replacement. And what does g do to something? Well, same thing. It does 1 over that thing. And 1 over x is just x. So in this case, coincidentally, they turned out to be the same as well. All right, question E. All right, question E, f at g of x. So g of x in this case is x squared minus 4. Let me make that replacement. And you know, f of x is just x, so that means f of whatever is just that thing, right? So f of this is just x squared minus 4. And when we do it the other way, what happens? Well, f of x is just x, and so we just get g of x, which is just x squared minus 4. So this one's kind of special. If you have one of the functions being just f of x equals x, then f composed with g and g composed with f actually just turns out to be the other function g. All right, so the last question here is f. Here are the formulas. I'll have to take them off screen here to make everything fit. So f composed with g is what? Well, g is x cubed, right? So this can be written like that. And f at x cubed is, well, we got a square. I mean, let me just write it like this first. It's whatever squared plus 2 times whatever minus 5, right? And in this case, the whatever is x cubed. So let's make those substitutions. So we get x to the 6 plus 2x cubed minus 5. And for the last one, g at f of x, what happens there? Well, f of x is this quadratic. And what does g do to it? It cubes it. G cubes anything that we put inside those brackets. So, and we will not multiply that out. It's fine the way it is. And that completes this question.